Good morning, everyone. Welcome back to the OpenShift TV Coffee Break. Here at OpenShift TV, we have our architectural tech talk with all about OpenShift and Cloud Native. Today, my name is Natalia Vinto, Product Marketing Manager for OpenShift here at Red Hat, and today I'm very pleased to have as a special guest the Red Hat Hackfest community. So, welcome, Andreas, Mattia. How are you today?
Hi, Natalia. Thanks for the invitation and thanks for this.
Hi, Natalia. All good, thank
you. Morning, Natalia. Thanks for the invitation.
Good morning. My pleasure. My pleasure to have you folks here because I know the community ran another successful Hackfest, and I would like to let you tell us what is the Red Hat Hackfest, what is this community. We had the winner of the Hackfest in last month, no? They joined us, the winner of the Hackfest. We talked about all the project. Today, I think it's also another opportunity to talk about technical aspect of the project with the community. And I know Andreas has lots of technical stuff to share with us. I'm looking forward to it. But hey, folks, do you want to introduce what is Red Hat Hackfest?
Yeah, sure. Natalia, we had several opportunities to meet here and to explain and talk to the OpenShift Coffee Break audience. It's a continuous development now. So Red Hat Hackfest is an event that Red Hat delivers to its partner ecosystem, right? We just want to bring partners together to have fun, get challenged with technical solution or technical implementation, and also the whole process brings to the partner ecosystem and to customers, other than the community, a huge amount of technical tools that they can reuse. So we try to build repeatable, consumable, and scalable components for enterprise architecture. An important thing to mention here is that we try to focus on solution over products, which means in turn we work on digital transformation or specifically edge computing solutions, trying to make sure that we cover one vertical at a time. So there is the vertical, there is the customer success, there is the partner success, and also the idea of look at a bright future in terms of reliability, right? So this is what we do. The community, and we have some very, very esteemed members of the community, works hard to implement something for the event and then support afterwards the partner ecosystem participating in it, and mostly the winners, of course. But I'm happy to hand over to Andreas or Mattia if they want to add something from their perspective.
Go ahead, Andreas.
I don't want to talk. Well, not much to add to the introduction. I'm the only infrastructure guy here. It's also quite interesting to talk about that. So this is I'm doing the infrastructure part, and as you know, we're not only talking about stuff running inside a secure data center. We're going towards the edge, and that's also a very interesting and special aspect. Once you take your workloads that you used to run on huge servers, and then suddenly they have to be executed and stuff like that on the edge, and that's also an important and interesting part to go.
Yeah.
Andreas, you said that you are the infrastructural person with some, you were proud about it. It looks like you are all with, those cloud native developers here. So how is the life of the ops guy inside the dev team?
Well, the thing is for the ops guys today is we're getting closer to developers. That's one of the big changes that we have in that scale out, in that containerized world. We need to learn some of the principles that are standard for developers that we didn't have before. I'm very much in the automation business with the Ansible environment. And if you take a look at the changes inside the Ansible automation, now operators have to deal with Git, with versioning, with build chains for their whole stuff. They weren't used to that. So the work of the operator gets more dev style each day. And if we talk about the things that we built for the Hackfest, the distribution of the workloads, the downloading of the workloads from the data center, offloading them to the edge, these are all processes controlled by automation and operational setups that align with principles that developers typically use and not operators. So that's one of the big changes for the infrastructure, for the operator guys, is to learn these things and get used to these things. That's one of the big disruptors, I'd say.
Yeah, thanks, Andreas, for sharing these thoughts. I think you're right. I think there's a shift on the paradigm. No, more close to development. And Mattia, is DevOps the answer? I know you are a great DevOps.
No,
Is DevOps the answer?
it's not DevOps. No, yesterday I learned from the Cloud Native Foundation, there is a new job description coming out, Kubernetes engineer. Ooh.
Oh.
Ooh. So DevOps,
Ooh.
SRE, bullshit. Kubernetes engineer.
Kubernetes engineer. So is it a developer? What is it's a kind of software engineer, or it's a SRE?
I guess
let's say
it's a full stack, to be honest, because they need to be familiar with the infrastructure first of all, how all the components work under the hood, master, worker node, but as well you need to know how the application need to be deployed. How it works, how they integrate with each other. Communicate with pods, services, routes. Ingress. So it's kind of, you need to know the both world, and always say as well on my job, I'm not anymore a middleware or dev guy, but a kind of hybrid, right? Because you need to be familiar for the infrastructure, but as well you need to know how to use the infrastructure.
Right, and I would like also to introduce Marcus. Sorry, we had a technical issue, and now Marcus can join the talk. Marcus, do you want to introduce yourself?
Yep.
Live in the show.
Live in the show, yeah. Marcus Koch, hello. I'm a partner enablement manager in the same team as Andreas is. And my main focus is on SAP related stuff, and hence I'm I also look after the IoT solutions of SAP.
And that's why Marcus is a great resource for the community, actually. As I said, Natalia, we try to bring all the skills that the customers could need in one place. So that's a fantastic opportunity to collaborate.
That's pretty cool. There's Luigi in the chat saying DevOps engineer, cloud engineer, Kubernetes engineer, always the same story. You have to know everything. Right.
Yeah. No, Luigi, I mean, guys.
Yeah, I guess you need to know everything, but maybe not everything, but you need to know where to look at least,
Yeah.
Yeah.
But
where is the man page for the Kubernetes engineer?
Exactly.
Because, when we started, now I'm 42, I started more than 15 years ago developing Java. So I started as a Java developer. And back in the days, I believe they are still looking nowadays for full stack engineers. But the full stack engineer definition a few years ago was you should be able to develop something on the database, something on the application. You should be able to do a couple of bash scripts, but you should know also web interfaces, backend, blah, blah, blah. So that was a definition tightly coupled to the software development. So based on what now everybody is saying here in this session, the full stack engineer definition shifts slowly in between the dev and the ops, right? It's weird to me, and maybe this is off topic, but this is actually what we are trying also to understand within the community, discussing on a weekly basis, how deeper into the technical details of the platform or the operating system a developer should be. I mean, now we have Mattia and Andreas here, and also Marcus, who are great champions in different areas, right? Again, I'm a developer, but usually in the community, you don't see only Andreas and Marcus from the infrastructure side. we have 80% of the members specialized in RHEL or operating system in general and container platform or virtualization. So this full stack Kubernetes engineer definition is kind of weird to me, if I may. And I agree with Luigi, actually.
Yeah. So Mattia, what was the outcome from the webinar? From the talk?
Did you mean the
Kubernetes engineer,
DevConf?
the new?
No, it wasn't a webinar. It was on the Cloud Foundation.
Okay.
So yeah, the cool word for your job description. So please update your LinkedIn profile so everyone we offer you a job, right?
I don't really agree with you have to do everything, because that's the whole idea. If you make it right, if you set up the environments right, the operation guy is giving you everything you need so that you don't have to worry about the infrastructure. Look at technologies like workspaces or Eclipse J. What's the upstream project? If you set that one up right, the developer doesn't have to deal with, where does my stuff run? How do I set up my hardware? How do I get my development environment? Because operations is doing that for him. So, and this is something newer than we had it throughout the last year, where the developer really had to dig down into infrastructure. How do I get my setup right? How do I adjust my software so that it runs with that environment that I'm on? And that's what we try to get away from, and give the developer more freedom to say, here, website, code, run it, click run. You don't care where. That's all that serverless and the things that we talk about. So yeah, we should be able to take the developer off all that infrastructure if we set it up right.
I think when I say you need to know everything, it means that you need to know how the platform works. It doesn't mean you need to go deep dive on the node to understand what's the issue, to see the PID container or whatsoever. And as well, also for code-ready workspace, like you mentioned, it's about standard. I use the developer tools. Everyone uses the same way or consistency of working. So it just the developer in theory should need to care about implementing the application and not how to install Java JDK, right? Because the container has already the JDK for you and standard for everyone, and so they just start working.
Yeah, I agree. A container as a standard format where you can converge. No, all the apps are container based, so it's portable. It's the same standard way to do stuff. We have people in the chat. Good morning, Fabio, and also the first question from Pradeep. What is Pod Sandbox in OpenShift 4? I think it was talking about the Kara container part. Is anyone from you knowledgeable about Sandbox container in OpenShift? That we can share some info before we go into our topic.
Yeah, it's about Kata container, but unfortunately I haven't a chance to deep dive on that.
Yeah, okay. I will share in the chat the link to Kara container on OpenShift, so you can check the documentation to get more. And thanks for bringing a question to the chat. Please send us a question to the topic we're talking about. And Andrea, talking about topics of today, can we shortly resume and talk about what is the Red Hat Hackfest and what are the technology involved, and then we go again in the technology details.
So it's time to talk technical, isn't it?
Yeah, tech talk.
Let's share, Natalie,
sure.
my screen. Just a quick overview. We implemented some use cases preparing for the Red Hat Hackfest. And this is the last one we've been working on. The reason why it's use case 2 is because we usually work on the same use case for 2 Hackfests. This is worth thinking of the huge bunch of technology we put in and that we rely on. And also it's important to have a continuous development also for the people who join the community, because the community is not only meant to do something enterprise for Red Hat and its ecosystem. The community, of course, it's an open source community, so we do everything we can to bring other people in, to learn from others, and to have an exchange of skills and knowledge, right? So that others can join us and see what we do, and of course suggest. So the use case we implemented, and we are happy to speak about today, also digging deeper into some details if our audience is keen to ask questions, is a manufacturing use case. Manufacturing is quite interesting. It could be converted easily into energy and utilities. In that case, converting converting use cases for a specific vertical into other verticals is always a matter of technologies underneath. But generally speaking, the architecture should be flexible and extensible enough to make sure that can be scaled out once it's needed. So we had some hardware provided by our friends from Intel, and we implemented both the edge device and the edge server piece, simulating a production facility. So many edge devices controlling stuff or receiving data from sensors and whatever are responsible for the machineries producing something. Then the edge devices are responsible for the control of the machineries and for sharing the telemetries, several telemetries to the edge server. We implemented the edge server using single node OpenShift on top of the Intel NUC device, which is something we got actually certified. So Intel BU and Red Hat BU agreed on certifying our solution because that was worth to have it for several medium and large customers. Last but not least, the data center side is implemented on top of the OpenShift container platform, and that includes and is shipped with several third-party technologies. It's not all about the Red Hat stack, right? So the technology stack starts from the hardware underneath, goes through the platform, and by platform I mean operating system, Kubernetes, and several other components that make that connection between the other layers, so the hardware and the business logic. And last but not least, we've got several products together with what we have implemented in terms of microservices, applications, and whatever, that make the environment work. So the data center plant is responsible for security, workload distribution, and also the business logic that is tightly coupled to the use case we implemented. I don't know if there are any questions in the meantime.
So, Andrea, there was some question actually from our attendees from Twitch. For instance, it's related actually to OpenShift. I don't know, since in the Hackfest we worked, the community worked either on the edge part, but also in the OpenShift part. So
Indeed.
one of the questions is, are we by any chance working on an OpenShift sizing tool? We don't have something easier for that. I remember we had this, what we called a lab for OpenShift 3. It was a sizer tool. But do you have any helpful answer for any best practices to size the OpenShift cluster? How did you, for instance, in the Hackfest?
Well, not strictly related to the Hackfest, but usually when you go on customer, OpenShift is kind of a dynamic platform, right? So first of all, you start with the basis, then you set up all the monitoring tool around capacity size, right? And together with the auto-scaling capability, you're able to scale out the cluster based on the workload. You always have to keep a threshold, right? 80% of the workload, then you start auto-scaling. But because it's a dynamic, I don't think in dynamic way a sizing tool can be a guideline, but you should not take it like a Bible, right? Because your workload always changing. Because maybe in the next day, the under application, they're going to join your cluster. So how you do the sizing will wrong anyway. So if you have auto-scaling, automation around the scalability of the cluster, then the sizing tool, you don't need anymore. Just start with the basis and then scale out. So start simple and then go bigger.
Yeah.
Well, you got to see it a simple way. OpenShift is the new Linux. Let's say it that way. It's just the platform to run your application. And there's no standard sizing how you set up a Linux environment, because it totally depends what you run on top of it. So we cannot have a standard tool for how do you do OpenShift. So the thing that you need to do is you create your application first. You take a look at the workload that your containers create and that your application creates. And based on that, you start the sizing. So the sizing is not for OpenShift. The sizing is for your workload running on top of OpenShift.
That's a good point also, and I agree what you both say, that with OpenShift for maybe the architecture is more dynamic. You can really scale up, scale down on the need. You can collect metrics, and then there's tools like if possible, the cluster autoscaler or the machine set. Those automation that is delivered by the adoption of the operator pattern also for the operating system and the core component. It's help you to shape your cluster. I think it's a good point, both Mattia and Andreas. And in the chat, we have another user that say that always used Ansible for preparing the devices for the developer. So another good story to share. Andreas, I know you have your Ansible t-shirt as well. That looks very cool. That's cool. So please share in the chat your experience and please send question. It's an open conversation. Really cool. Thanks.
Yeah, actually, the thing is that what we did as a part of the QIoT initiative is that we used Ansible to actually deploy the workloads to the edge. That was one of the components that we're still working on and improving. That is because the idea is you have the data center in the cloud, then you have the local edge server where you have the OpenShift, where you have your factory pods running, and then if you need something running on the edge, we have a couple of methods to do that. And for our initiative, we decided to run the pods that you create for the edge on Podman on the edge device. So what we built is we built an edge RHEL for edge setup to set up these Fitlet devices. And then we took Ansible to deploy the containers that will run the edge and actually push them to the edge and have them running there. So this was one of the things where we actually used Ansible for, and which is a good fit to do that, and that was part of the whole setup.
Very interesting, Andreas, and I'm curious to know more about it. Do you have some slide to share that I have to bring up?
No slides on that, but rather code.
Yeah. That's it. Because I see, Andrea, you have some deck here. I don't know if we have
to share if you want. So to give to our audience an overview of the technical perspective here. There are two big topics we are keen to discuss today. Also, other than the question we can get. Of course, one of them is managing edge devices. Now, Andrea is our Ansible and RHEL champion here. So other than what we have done, so managing the workload, we are thinking of, and it's a matter of time, of course, we're thinking of several alternatives to what we have done. And I will let Andreas discuss it. So I'm talking about Pixie Boot and several different opportunities. Also, management of the edge device with Ansible is key. And this also connects to what Mattia is bringing to the community. So he's an amazing Java developer, but he's also very, very expert in security. So thanks to his recommendations and skills, we introduced a key component that is quite interesting to customers, actually. So to who has the ownership at the end of the implementation phase of the whole environment and landscape. And this piece is what we call distributed security, or through mutual authentication. So we know also there are several ways of implementing security. I will hand over to Andreas and Mattia to explain more after this quick technical overview. So I'm presenting here, and let me also zoom in more. Yeah, that works, I guess. Technical overview of the architecture for the production plant. So the edge server, of course, is responsible for two things: connect the data center with the devices, but also run several algorithms and processes that make sure that the devices are managed properly, registered, eventually decommissioned if they get hacked, distribute the certificates for the security, and last but not least, handle the telemetry. Telemetry, of course, could be based definitely on the Open Telemetry standard, which we are investigating thanks to the recent adoption also in the Quarkus universe of that component, that module. And also, telemetry could be decorated. So that's why we need algorithms and business logic in the edge server for the telemetry specifically. So there is a continuous interaction between the several edge devices owned by the factory and the factory itself. And that's why, of course, we introduced this additional layer: data center, plant, factory, and machineries. And the machinery is also, at the moment, as Andreas stated, we are using Podman. We are also investigating Microshift. Microshift will also lead to a more centralized control and overview through some tools. I don't want to take over I don't want to steal the words from Andreas' mouth, so I will give him the chance to discuss everything. Interesting things. Snow, so single node OpenShift, works like a charm. We have been eager to adopt this solution a few months ago, when back in the days, still single node OpenShift was about to be released GA. And we have to say that worked pretty well. Also using some standard tools from Red Hat, like the automated controller. So this is something we are happy to disclose and discuss anytime. So I'm done with the overview. If you have any question for me, or otherwise I can hand over to Andreas and Mattia.
I think this is Andrea. Thanks for sharing the architecture. I think this is really cool because it gives an idea on all the components. So if you want to start a project involving edge devices and application, event-driven application, ingesting lots of data from the sensor or edge devices, IoT devices, this is really cool because the people that would like to understand how the project works can have from this overview either the client part, then the server part. It's very interesting, and the technical details are in the Quarkus for IoT project GitHub project repos that we will share in a moment. So it was very interesting. Maybe we can go now, if you like, into the edge part. I think it's very interesting to understanding also this part. And I would like to thank you from the chat. There's a Twitch user that said, this chat you all have is there where I learn to automate with Ansible. You are all amazing. You learn me something every time I watch something from Red Hat. This is really cool. This is why we are here. Thank you very much. Thanks everyone attending. I think those are very interesting tech talks, and I'm looking forward to hear more from you folks. So what is this edge part, Andreas? Can we talk about more about it?
Sure. The edge part is, when we go to the edge, we have some different ways of running things on the edge. As you know, we're talking about a setup in a factory with a device attached to a piece of machinery. Everyone who worked in a factory, you see these machineries and they have this big red button which says stop. In case something goes wrong, you just hit the button and the whole machine shuts down. If you combine that machine with IT, the thing that you cannot have is, somebody getting stuck into the machine and says, help me, push the red button. And the operator says, oh, I have to cleanly shut down the control PC first. Otherwise I get data corruption. It's not going to happen. They hit the red button and the thing turns off. So when you create compute devices attached to this type of machine, you have to keep things like that in mind. So that's why we have an image builder. In case you're not familiar with it, let me get that into the picture if you're interested.
Yeah, thanks. In the while, I shared the GitHub repos in the chat, and Andrea was showing this is the homepage of the Quarkus for IoT project, where you see the article from the community. Andreas wrote an article on how to install RHEL for Edge on Compute Lab Fitlet 2. Andreas, you are sharing the screen, so let me switch over your screen.
That's okay. So the thing that we have here is just a standard tool. It's a part of every RHEL installation. It is based on open source, of course. It's based on two systems called Lorex and Welder, which is an image builder. As you can see here, what we have is just a virtual machine with Cockpit. As you know, we use Cockpit on port 1990 as a graphical way to admin system that makes it easy to work with. And we have Marcus saying that it's available as SAS tool. Yes, we have it on the console.redhat.com. If you go to Linux, I don't know if it's open for everybody.
Wow.
Yet.
So it's a SaaS tool connecting to
Cockpit. But it's where is it? Yeah, it's I have to go to the beta page of that. So what you already can do is, if you don't want to install everything on a standard system, you can go to cloud.redhat.com and use the image builder from there. I haven't tried it yet to build edge images, so I'd be careful with that. But it's an easy step. You just set up a RHEL system. For those who say, I want to play with open source first, take CentOS or any Enterprise Linux 8 clone that is out there. Just install Cockpit, install the image builder. It's described on our system. And then what you get with a front-end tool inside Cockpit is that image builder tab. And what you see here is the build setup that I created for the Fitlet device. So that means is you create something that we call a blueprint. And in that blueprint, you pick and choose what you want to have in your edge image. So for our case, what we built is we put Cockpit in and Cockpit Podman. And, that's just for the old guys that still like Norton Commander clones. You put MC into that setup. And then, of course, Podman, because we run our applications as pods on site on the edge. And so you just pick and choose the stuff that you want to have on your edge device. You do add a user, you add an SSH key to that so that you can log into the remote machine, and then you create an image. And the interesting part here is the tool initially is designed to give you the opportunity to create an operating system image that you can run everywhere. So you create your golden master, you run it on vSphere, you run it on Amazon, you run it on Google Cloud, whatever. And the image creator is exactly for that. It gives you different types of target image that you can build from your blueprint. So the interesting part for us is the RHEL for Edge commit, which means is we take all that stuff that we want to have in that Fitlet device and put it into a structure. Can you increase the font? Let me give that a try. How does it work here?
Yeah, if you can a little bit increase the font so that people can see, because this window will be embedded. That's pretty fine, thanks.
Okay, so and then you have, so the RHEL for Edge commit. So what happens here is that we take all the necessary things we need for that Edge device built and put it into a directory structure. And what we then do is we can boot that remote device off a standard USB stick and then point to a standard HTTP server to draw all the packets from, or we can PXE boot it. So it is in the description that I wrote on the webpage how you would install it standard, create the RHEL for Edge commit, put that on a simple HTTP server, and then boot the remote device from a USB stick pointing to that HTTP directory for the installation. You can also PXE boot that. We can take a look in how I set that one up so that you have a networked environment where you grab the image automatically. But the important case about what we do here is the moment we build that edge device, we have an OS tree setup, which means is we do not have a full-blown operating system with DNF yum to install packets. What we actually create is a Red Hat Enterprise Linux image that comes with a read-only root. It doesn't have DNF. It has the whole operating system in an OS tree image from where it boots from, and only has var and etc mounted read write. So in that case, if you turn off that edge device, with the red button, you won't damage the root file system because it's mounted read only anyway. And then you can go on and push your edge loads downward to that. So that's the interesting piece. And again, the image builder also is available on the console. It's currently in tech preview, so it's not directly showing up here in the standard setup, but it will show up here in the as a tool button and say created. So is it here yet already? No, I don't see it yet, but it will be in the console for the Red Hat users. So that's how you build the edge. And then you have, like Andrea said, you have two options. You could run Podman, which we did here. So in this case, this is just an overview of a system that I'm running, where I run all the applications in pods. And that's the idea, what we did in the edge scenario. So we then took the workloads that we wanted to have and put them to the edge device and run them inside Podman containers. And as Andrea mentioned, we're also playing with Microshift as an idea. And the difference between those is if you have workloads that are closer to the hardware, maybe you have a workload on the edge device that needs to access the GPIO or a USB device that then is wired into the machine. You want to stick closer to the hardware. In this case, you would preferably run that with a Podman container in a privileged mode and wire the hardware into that so that it can get control over the machine. If you have edge applications that are more in the compute space that don't need I/O or such kinds, that you do calculation power or that kind of stuff, you could run with Microshift. Microshift, for those who don't know, is, let's go to the Microshift.io. Don't type in Microshift blankly. You get to a web page of an American company manufacturing shifts for mountain bikes, so because they're called Microshift. So that is a very stripped down, simple version of OpenShift that really comes with very low requirements for CPU and memory, but it works with the kubectl or OC command set, so you manage that on the command line, and that's really great. And this is more targeted for the workloads that you directly want to take from your OpenShift. So where you build your containers on top of OpenShift to run with Kubernetes and Cryo, and you want to put them on an edge device. So Microshift is one of the paths that you can do. And by the way, this one not only supports full-blown Intel-based devices, it also should run stuff like that. In case you haven't seen, this is one of the NVIDIA Jetson experimental boards. I haven't had the time to set it up with Microshift yet, but it should work that way. We had a demo on DEF CONF ZZ earlier this year, where some of our colleagues in the Czech office used that. So what you then can do is you even take AI workloads that make use of CUDA and the NVIDIA chip on the board to do AI ML calculations on that. So that's quite interesting.
Wow.
Then you can use Microshift stuff. And since we had someone talking about the Ansible stuff, what I can quickly show you before I hand it back, where's that tab? So oops. So now it's getting a little bit more getting towards the command line. Oh crap, yeah, I hope this is readable, because we're now We're now on an OpenShift on a Microshift environment. Font size, yeah, I know. Let me check that. Settings, standard. Let's go to something bigger than that. Okay. Whoa. So that should be readable.
Wow, that works.
That works. So what we have here is actually a virtual machine, simple virtual machine running that Microshift service. And as you can see here, everything you need is, all the OpenShift is, except for the Nuba container here, that is just a bunch of pods running the Microshift service itself. Really, really simple. And Luigi was asking, what hardware does Microshift support? ARM. Yes, it does run on a Raspberry Pi 4, also. So that one is just a virtual machine running Intel. But also because we had the question from someone saying, I'm doing everything on Ansible. So if I go into OC project AWX, project, you can use Microshift to run your AWX environment. So, and it is like OpenShift. So you have the AWX Postgres, you have the node port forward so that you can get access to your AWX installation. You can run OpenShift operators on that one. It's really simple. So I have that OpenShift and not OpenShift, that AWX setup running and can make access to that and use this to run any kind of workload that has an operator on that simple environment. So this is actually the OpenShift that the AWX Ansible setup that is actually running on top of that Microshift installation. It is that fairly simple. So this is a great tool, and we're going to use that in a future version of the QIoT project for, again, the workloads that are more related to compute rather than control. And if we go to to USB ports and stuff, and then we stick with the Podman setup. So that's something you should play with. It's actually nice, and we're gonna include that into the QIoT project soon. So that's from my side. So let me get off my screen.
Brilliant.
And quickly, Natalia, sorry, to add to what
Yes.
Andrea said, we have weekly meetings, and we also have these blog posts and the community work. We are on GitHub, and if thanks, Natalia. We are on GitHub. Everything we discussed here has been implemented and shared, so it's distributed to the community. If anyone is keen to learn more, cooperate with the community, Andreas, Mattia, myself, Marcus, and also Natalia, because Natalia is another esteemed member of the community, and the other champions we have, feel free to join us, feel free to reach out to us. We've got a Slack channel, which is linked in our landing page on our blog site. And so you can see here Slack, LinkedIn, and also the Twitter account and the mailing list for the community. Thank you, Natalia.
Welcome. Yeah, that's very interesting. I'm going to share in the chat the Slack link. Before we do it, there was a question, Andres, in the chat from Luigi. What hardware does Microshift support? ARM is supported. I know that a user from Twitch sent the link to the Microshift documentation, but do you know which hardware is supported?
So the important thing is, if we talk about supported, Microshift currently is an open source project initiated by the Office of the CTO of Red Hat. So it's not an official product. It's an upstream project. So supported, goes both ways. So we of course it runs any kind of Intel platform, and it runs 64-bit ARM devices. Now, of course, the prerequisite is that you get an operating system supporting the Cryo engine on top of your ARM board. But this could be a kind of ARM Debian 64-bit version. It could be Fedora on ARM. It could be RHEL or CentOS on ARM. That should work. Again, I didn't have, my Raspberry Pi 4 is doing other stuff. So I haven't tried it yet, but it should work on 2 CPU cores, 2 gigs of memory, Intel or ARM64 architecture. So again, what I have in mind is, use this, what's that? It's an Odroid C2, which is 64-bit ARM technology, and using on top of that, since my Pi is busy doing other things. And that should work. But again, if you just want to give it a quick try before you, start messing around with setting up the ARM piece the right way, just spin a simple virtual machine, 2 CPUs, 4 gigs memory. Everybody can run that on top of their notebook somewhere else. Get in basic Fedora. If you follow the Microshift documentation, how to run, the easiest way is get Fedora 35 and follow the path saying RPM installation, not the Podman installation, because then you have two, Podman and Cryo on top of one system. Doesn't make sense. So you just run Fedora RPM installation with Microshift RPM from the Copper repository, and you're up and running in 5 minutes. It's that easy. And then once you got a hold of that, you can start trying with your ARM setup, and it should work from, let's say, Debian or Armbian. That one runs Armbian. There's a guy, Victor, I forgot his name, who is creating a Debian. Has created a Debian distribution for all those non-Raspberry Pi ARM devices, which is pretty good, and it should work with that one. That's what I intend to try this Odroid with, is the latest version of Armbian, which is based on Debian 10, and do that. So there's a question from, do you get a GUI in Microshift? I as a Red Hatter was afraid that this question comes up, but we're talking open source here. As I said to my colleagues, there is no official GUI from us, but they're the competition. But there's some guys that create something which is called Lens, and Lens is it's a UI for Kubernetes environments. It is from Mirantis, the competition, but actually Lens is a nice. It's an Electron app, so it works on the Chromium runtime, and you can manage anything Kubernetes with Lens in a GUI fashion. So no matter if it's OpenShift, if it's self-hosted, plain Kubernetes, or Microshift, so you can use that if you want to have a UI. Even if it's a product from the competition, it is a nice product. It is open, and you could use that like I do to manage your Microshift. So in this case, if you want to take a look at it, you can have, I just shared the screen with it, so you can have an overview about your node. So in this case, I don't know if I can make the characters bigger on that one, because it's does it work? Does it take the, no, it doesn't. So in this case, you can have multiple clusters, and that's the one that I was just showing you. So you can see this is the virtual machine. That one actually runs Rocky Linux for testing. So we do a lot with open source stuff. And then you can have an overview about your system. So you can see all the namespaces that you run in. And that one actually is the AWX setup. And I can see my containers, and I can go to my deployments, and I can work on the replica sets like
it's inventory of all the Kubernetes objects.
Exactly, but you also have an inbuilt editor where you can go in and directly interactively change the YAML stuff and so on.
So, and as you suggest, to have a kind of a IDE, for instance, the Kubernetes connector for Visual Studio, it's similar to that, no? But this one, it's an application that
it's an application. It's Electron. It runs on Mac, Windows, Linux, wherever. And for the ones that don't want the CLI to manage their Microshift environment, that one's really easy. It comes in handy. I know it's from the competition, but it's a nice application. So no one, we're open with that. And if you want to have a GUI and make your life easier with that, go that way. Of course, the hardcore operators will always use the CL commands on.
But Andreas, Mattia was saying in our private chat, now the ops loves the UI. It's hilarious, no?
Yeah, no VI. I have to build an image. Now all click, click, click.
Yeah, exactly.
But it was
nice
very
to
interesting. Thanks for sharing, Andreas. It's an IDE for Kubernetes. You can check, you can monitor, you can work with your Microshift. Very, very interesting. Thanks for sharing it. Folks, I would use those minutes that we have left to ask to Mattia a little bit more about the OpenShift part. So, and then Andrea would close up with the final question about the community. How did you build this wonderful community? But before that, Mattia, can you share more, technical details on the OpenShift part for the project? I know this project now, this Hackfest, is 3 years. Did the architecture evolve during these years?
Yes. So when I was first involved, the architecture was simpler. We got just a central OpenShift platform, and then directly the edge device. And when working with edge device, we want to have also secure communication with the edge device. So we need to find a solution that was scalable, right? And just a disclaimer, my idea was to leverage a service mesh to have a common mesh, but service mesh at the time was not ready for use case for an edge device, and so on and so forth. So we decided to use the standard Kubernetes for certificate management, which is Cert Manager, and to spin up certificate as well for device, because when you spin up you request a certificate, you can define the specific common name, subject alternative name, so you can have a kind of hand-to-hand integration with the device. And as well, the nice things about Cert Managers is quite agnostic of which certificate authority we use. And for our POC or Hackfest, we simulate the customer certificate authority using HashiCorp Vault, which provide a PKI secret engine. And then on the second round of the Hackfest, we kind of improve the architecture. We simulate kind of a data center and a factory with OpenShift Snow. And in this case, you want to kind of not just scale out to the edge, but as well the factory, and give the power of the factory to spin up certificate for the device as well, and as well the application running on the factory. One of the best practices in standard, you should never use root certificate authority, but you always need to delegate with an intermediate certificate authority, because the root certificate authority is just the purpose of the root certificate authority is just for spin up intermediate certificate. And then the intermediate certificate will be used for application certificate, and in this case, for our use case for edge device. And so we improve the architecture and with the intermediate issuer to allow the factory to spin up a certificate for the edge. What I will see as the next step, I hope to implement in the next aspects, will be to leverage the Service Mesh Federation capability, which allow you to unify several cluster device in a unified mesh. And as well, the service mesh can be integrated with Cert Manager, so the part that we build can be reused. It's nothing to throw away.
Depending, of course, on the resources available at the hardware level, right?
Yes.
I can clearly remember Natal and myself working on the first, on the Hackfest pilot and the first use case. We were sizing now and having a discussion on the size of the environment for the OpenShift platform. And Natale clearly stated, if you want service mesh, please double the resources, please double the requirements. So that's why we shifted to a different solution. Still supported, it's still enterprise grade, hopefully, so not hopefully, clearly less automated than the service mesh itself.
Yeah, at that time, Andrea, service mesh wasn't. We weren't supporting the modern topology of service mesh. Now Istio support also ubiquitous heterogeneous environment. Can be from OpenShift. We will have the support also of external virtual machine running the mesh. So not only OpenShift workload with service mesh, also non-OpenShift workload with service mesh. This is interesting, in the edge perspective. So maybe if we had that technology 3 years ago, maybe we were rethinking about it. But for the future, why not? Also, Mattia said it's a valid solution. It's something we can reconsider. And if you are interested in that, please join the Hackfest community and to discuss and participate on that. From the chat, there's Tolitzaso watching from the Philippines. Hi, welcome to OpenShift TV Coffee Break. Welcome. We are here with the Quarkus for IoT Red Hat Hackfest community. Andrea, we have some minutes left before we close. I would like to ask you. The question is, how do you create a successful community, and how do you keep this community engaged over the years? I know it's a hard one.
No, well, thanks for the question, Natalia. Actually, you should be the one. You can reply as well. I mean, we were the three of us, you, myself, and another colleague of mine, and Andreas and Marcos, Owen Crosby. And we did a lot of work to implement the whole POC on our own. But then afterward, we started receiving some joint requests or sharing requests. So we decided to form this community. Again, it's important to collaborate. We are professionals in love with the technology, and of course, working in an open source environment. And this is the only thing that matters, right? Sharing. In Red Hat, we say sharing is caring, and I believe this is true. So other than calling out to action within Red Hat, I decided to do something together. So to try to call for contribution, the community itself. So, and also the partners participating in the events, because they were also individuals or entire companies. They were trying to figure out a way of keep the collaboration going and quite live. So this is what we got so far. I mean, I'm amused by the people the joining the community from time to time, or the old members like Andreas and Mattia and Marcus and the other champions that cannot be here today for customer engagements or other various reasons. But I want to mention them: Ben Taliart, Mario Parra, these guys, Jeff Newson. These guys, they have made possible to not just develop stuff, but also have an open view on the future opportunities from the technical standpoint, and have this all together now, and it's fantastic. From time to time, we have other people joining, not constant or continuous contributors, but still people who give a value and who can have definitely a voice. And also the whole community wants to thank you, Natalia, and the whole OpenShift Coffee Break group and administrators, because you are contributing heavily to the growth of the community itself and the successful Red Hat Hackfest event from Red Hat. So thanks a lot.
Thank you all for joining today. We have also people from the chat saying hi. Luigi saying great discussion. Thanks, Luigi. Andreas, there was a question from Michele. Michele said lens ad hoc for OpenShift is necessary.
I don't fully understand what he means. Lens ad hoc for OpenShift. OpenShift has its own inbuilt web UI. It doesn't need anything. But if you have a lens installation and you use it to manage, several Microshift installations, you can also get access to your OpenShift with that. But OpenShift doesn't doesn't need it, because out of the box, as you know, OpenShift has its own dashboard, which has more information than an UI like Lens. So you don't need it for that.
Thank you. And we have also people from New Zealand attending today. Why? Wow, fantastic. All over the world, no, is attending. Thank you all for joining today. It was very nice conversation, very nice tech talk. Thank you, Andreas, Andrea, Marcus, Mattia. Thank you, everyone, for joining. So, Marcus, I would like to ask you, since we haven't chatted too much. So, what are your final thoughts? Why people should join the Red Hat Hackfest community? What do you think?
Oh, well, basically, this is the edge of the edge community, I would say. So there's going to be a big market. You see that even large companies like SAP is looking at the edge market to feed their backend systems, their business logic, etc. So that's basically why I'm here, because they make the money out of the databases and the correlation of the data, and need this data to be fed. And one of the largest possibilities to blow up their databases to earn money is edge. So yeah, it's a market, and the key is getting this data and turning this into data that can be used to increase the customer's business. Only those people who get intelligent or new information out of this massive data, that going to survive, and hence this is a market.
That's a very good point. Thanks, Marcus, for closing up with these nice words to describe why the people should join the Hackfest. If you want to join the new edition of the Hackfest, Andreas, I'm putting the link to the landing page of the Hackfest. If people would like to know more, would like to ping you, Andreas, Andrea, Mattia, Marcus, on any question, any technical or business question around the technology involved in the Hackfest, please reach out to them. You have all the information. And now, folks, thank you very much. I would like just to leave you with some reminder. Today at OpenShift TV, we have our Ask an Admin show, and then we have the show Red Hat Enterprise Linux Presents. Stay tuned on OpenShift TV. We will see each other on OpenShift TV Coffee Break next Wednesday. In the while, have a good day, stay safe, stay healthy, and talk soon. Ciao.
Take care. Bye-bye. Ciao.
Bye, everyone.